You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome, everyone, to another look at what's moving in tech. I'm your host from Vocal Technologist.
Glad to be here.
Today, we've got a great stack of sources covering, well, quite a bit. Data engineering shifts, how the big platforms are changing, some really clever scaling solutions, and, of course, the bleeding edge of AI.
It's a lot happening all at once.
Exactly. And our goal here is, to cut through that noise for you. We want to pull out the important bits, those key insights, and hopefully give you a few aha moments without taking up hours of your day.
Get you up to speed quickly on what actually matters.
Precisely. So let's start maybe with the big picture, the data landscape. We hear a lot about Databricks versus Snowflake.
Right, that head-to-head narrative.
Yeah.
But what's maybe more interesting is how their core business models are being, well, challenged.
Challenged how?
By these evolving data workloads. Especially real-time processing is forcing them to adapt constantly. It's not just about market share anymore.
Okay, so this pressure, it's not just them fighting each other. It actually creates openings.
Yeah, exactly. It makes space for other technologies to gain traction. Things like Apache Flink, which is really built for stream processing, or ClickHouse for super fast analytics.
Right.
And for data engineers, well, it means things get more complex. You're integrating more tools, trying to make everything work together smoothly as demands change. It's quite the juggling act.
So, okay, let's unpack this a bit. How are companies actually handling this kind of massive scale in the real world?
Yeah.
Without completely breaking the bank or their systems?
Well, what's fascinating is seeing people push existing tools sometimes, like RudderStack. Our sources mentioned they scaled PostgreSQL Postgres to handle 100,000 events per second.
Wow, okay, not Kafka or something more specialized for streaming.
Nope, they stuck with Postgres. And the insight there isn't just that they did it, but why. It shows that deep expertise with a tool, even one you might not expect, can sometimes beat chasing the newest, shiniest thing.
So how did they pull that off with Postgres? What were the tricks?
They tackled the usual suspects head on. Things like table bloat and slow queries. They used really targeted index optimization, very careful compaction strategies.
You're right, keeping those tables lean.
Exactly. And they tuned specific PostgreSQL settings, things like the write-ahead log buffers, checkpoint frequency, and, crucially, the auto-vacuum process to keep things clean automatically. Real deep-level tuning.
That's a great reminder to really know your tools inside out. Okay, so that's ingestion scale. What about, say, managing huge amounts of data that gets updated frequently?
Well, ClickHouse has a neat trick for that called the CoalescingMergeTree engine.
CoalescingMergeTree, okay.
Yeah, it's designed to efficiently merge updates over time. So instead of keeping every single version of a record, it intelligently keeps only the latest state.
Sort of like built-in deduplication for the latest view?
Basically, yes.
Yeah.
It makes queries much faster when you only need the current status of things. And for another angle, look at Illo's push notification system. They deliver millions of messages super fast using, the standard playbook, but executed well. Distributed message queues, microservices, batching requests, and scaling out horizontally.
Yeah.
Classic scaling patterns applied effectively.
Makes sense. Okay, let's shift gears a bit now. Moving from optimizing databases to, well, the wild world of AI, this is where it gets really interesting, right? What challenges are popping up with LLMs? We heard about prompt bloat.
Yes, prompt bloat. It's a significant issue. Basically, if you give a large language model a prompt, instructions, that's too long or just full of, clutter,
Yeah.
the quality of the output drops significantly. The model kind of gets lost in the noise, loses focus on the key information.
So you're saying less is more, basically? Just write shorter prompts?
Well, yes and no. It's more about being smarter with the prompt, not just shorter. There are some advanced techniques emerging.
Like what?
There's something called meta-prompting. You actually use another LLM to refine your prompt before you send it to the main model, like an AI editor for your AI instructions.
Oh, okay, that's meta.
It is. And then there's gradient prompt optimization. This treats the actual words in the prompt like parameters you can tune algorithmically to get the best output.
Seriously, optimizing the words themselves.
Yep. And then you have frameworks like DSPy or Scale Down that try to automate this whole prompt engineering process, make it more systematic.
That's a whole discipline emerging right there. So with all this AI generating potentially vast amounts of data, often in these vector formats, where does it all go? How do you store and access it efficiently?
That's where things like Amazon S3 vectors come into play. It's new cloud storage, but specifically optimized for these large vector data sets that AI models use.
Optimized how? Cheaper? Faster?
Potentially much cheaper, they claim up to 90% cost reduction compared to typical vector databases. And it simplifies things with features like dedicated vector buckets and APIs designed for similarity searches, basically making it easier to manage the data side of generative AI.
Right, streamlining that whole process.
And for the developers building these things, you also see tools like the LT Hub Workspace helping out. It can actually scaffold the basic code needed to connect to over 1,000 different REST APIs, getting you from zero to ingesting data much faster.
Smoothing out the development workflow. What a tour. From, the constant churn in data platforms and the need for smart, practical scaling, right through to the incredibly fast pace of AI. It really never stops, does it?
It really doesn't. And I think, the key takeaway isn't just knowing what's new each week.
Right.
It's digging a bit deeper, trying to understand why these shifts are happening, and maybe more importantly, how they actually change the way we need to think about building things with data and AI.
So always asking, so what? What's the real implication here?
Exactly. That critical assessment is crucial in such a fast-moving field.
That's a perfect thought to leave folks with. Thanks so much for walking us through all this.
My pleasure.
And thank you all for tuning in. Keep exploring, keep asking those questions, and we'll catch you next time.
Spoken Tech for your ears.